All right, here we go. Warm-up 119. Thank you for sending in your warm-up. Appreciate it. 119. Quick refresher. I'm going to do f of x base 2 in blue, given these values. So we got f of -5 is equal to 2 to the -5 plus 1, which is 2 to the -4, which is 1 over 2 to the 4th, which is 1 over 16. Check your work. That was -5. Now I'm going to do -4. F of -4 equals 2 to the -4 plus 1. That is 2 to the -3, which is 1 over 2 to the 3rd, which is 1 over 8. Next, base 10. F of -5 equals 10 to the -5 minus 1, which is 10 to the -6, which is 1 over 10 to the 6, which is 1 over 1 with 6 zeros, or 100,000. F of -4 is 10 to the -4 minus 1, which is 10 to the -5, which is 1 over 10 to the 5th, which is 1 over 1 with 5 zeros, and that is 10,000. Next, graph f of x equals x cubed. A cubic function looks like this. And then it says to transform it according to this, we move it 5 to the left and 2 down, 5 to the left, and 2 down, so our new function should be down here, something like that. Number 3, once again, we don't have negative exponents. We rewrite that, so that's 1 over a squared. Anything to the 0 exponent is 1. Distribute the exponent here and here. We end up with 1 to the -6 over x to the -6. But once again, we don't have negatives, so this goes down to the denominator, this one to the numerator, x to the 6 over 1 to the 6, which is just x to the 6. And last but not least, rewrite this, so this is 5 to the x times 5 to the -2. Fraction, 5 to the x stays in the numerator, 5 to the -2 goes to the denominator, changes to a positive exponent, 5 to the x over 25. All right, make sure you send that warm-up in, and I left you guys a couple of lessons to do the intro to the unit circle for trigonometry or pre-cal. I left you guys just simple stuff, but today we're moving on with rational functions, which is something that we need to finish up. So, send that in, please. All right, copy the agenda. Warm-up 119 done. We're still in the middle of rational functions, but today we're moving on to the new asymptotes. In the past, I had left you something like a video lesson similar to that, but today I just want to make sure I address this one directly. And tonight you have 4 slant asymptote problems. Make sure you get that practice in. Again, warm-up 119 is done. Rational function, slant asymptote, also known as oblique. And tonight's home plate, 4 of them. Let me send that to your screen. All right, code to access the home plate, write that down, VGNT3. 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 All right, we good? Enrique, you good? Yes, Enrique? You good? All right, good. All right. So, there's a hopefully for tonight. You're like, oh, snap, Mr. Q. Oh, snap is right. All right, get a Cornell note ready, please. And I want you to make, let's see. No, we'll do that when we get there. But for right now, get a Cornell note ready. All right, here we go. I can write, solve, and graph rational functions. So, remind your neighbor definition for rational functions. See if they remember from a long, long, long time ago. Rational functions, what are they? Functions that have what? Functions that have what? Functions that have what? Let's go with Joseph. Functions that have what? Rational expressions, yes. And what are rational expressions? In your own words, what are rational expressions? Let's pass it to Enrique. What are rational expressions that should be in those functions? Very good. He said fractions. And fractions that have what, people? Polynomials. Fractions that have polynomials in there. Okay, so far so good. From there, I gave you guys steps. You have all these notes. I gave you guys the general rule. From there, we went to our rational general rule. And then we focused on the first two asymptotes, which were the vertical and the horizontal. We did a lot of work with that. You guys remember that? Yes? Is it coming back? I know we've been off of this for a couple of weeks. Actually, let's see, 1, 2, almost 3 weeks. What? With all the testing, right? But anyways, we did this. We need to identify the VA, the HA. You guys remember that? Yes? And then from there we graph. And then we did these where you needed to do the long division and then rewriting it where the 1 goes on top and also finding the VA and HA. Those, and those. From there we got to this kind and the graph was different on this one. Is that correct? All right, for this one, look up, just a refresher. The asymptote is still here and here. Don't write this down, just pay attention. And the graphs are here and here compared to the original one that we started with. And then the rest is just transformations. That moves the one that I just drew, it moves it 2 to the right. This one moves it 2 to the left, 3 to the left and 2 up. Thank you. And then it flips it because of this negative that we need to move it to the front and so on and so forth. And then these kind where it has 2 asymptotes, vertical asymptotes, which is 6 and -6. And then the 3, which is still our HA. Which brings us to today. Look up. Copy this one, please, on your notes. Example 5. Right. G of x equals x squared plus 5x plus 6 divided by x plus 1. And I want you to make a coordinate plane to the right side of that. I'll give you guys some time. I'll give you a minute. Go. Lightning. All right, here we go. Y'all ready? So, first of all, what needs to be on top, everyone, in order for this to be a normal rational? A1, is that correct? But there isn't. We have a polynomial, Mr. Q. What shall I do? Say, neighbor, what would you think we do in order for us to leave a 1 on the numerator? Well, we do long division. Let's write this down. X squared plus 5x plus 6 divided by plus 1. All right, here we go. Let me zoom in. What number times x gives me x squared, everyone? Tell your neighbor, what number times x gives us x squared? What number? Caesar. What number times x gives me x squared? That is correct, x. So x times x is x squared. X times 1 is 1x. So basically we're distributing here and here. There it is. We're going to subtract, circle it, distribute it here and there. This cancels. We're left with 5x minus 1x is 4x. Bring down the next term. Continue. Again, what number times x gives me 4x, everyone? Enrique. What number times x gives me 4x? 4 plus 4. So 4 times x is 4x, and 4 times 1 is 4. Subtract. Distribute that here and here. So this cancels. And we're left with 2 as our remainder. How are we doing? Good? So, if I was to ask you to write the answer for that, what is the answer for that division? The red stuff, yeah? So our answer is x plus 4. But do we have a remainder? Yes. Remainder of 2. And the divisor is x plus 1. Thank you. All right. However, what is it? Does this look familiar? Yes, Mr. Q, but aren't we supposed to get rid of this so that we only have this fraction in the front? Yes. So, look up. We're going to move this to the back. However, the numerator, we cannot have a 2. Where do we move the 2 to? But remember, where do we move that 2 to? Enrique, pass someone. Who? Oh, Mario, where do we move that 2 to? Yeah, to the left, to the front. So let's see. We have the 2 in the front. We have a fraction. We have the x plus 1. And now we have this at the end, so we're going to put plus x plus 4. So now that we move the 2 to the front, what goes on top, everyone? A 1. So now this is our new g of x. You're like, that looks kind of funky, I know. But here we go, let's graph this. We start off with our VA. VA, x equals. Let's see. Turn to your neighbor, let them know, how do we find our VA from this? See if they remember. Tell your neighbor, how do we find our VA? All right. Looks like Mario's got this. But I'm going to go with Mr. Q. How do we find that? We'll take the denominator, set it equal to 0, and solve. So, minus 1, x equals negative 1. So my VA is negative 1. All right, next. We need an HA, or f of x equals. Now check this out. Look up to the screen. For the HA, look up please. Get off those phones. We usually just have a number. Is that correct here? But we don't have a number. We have this. So I'm going to write x plus 4. That's my HA. So let me zoom out. So let's start with our VA. Our VA is -1. So let's plot that. -1 is here. And then sketch your asymptote right there. But now we need to sketch fx equals x plus 4. You're like, what? Here, let me write it over here so you guys can see it. F of x equals x plus 4. That's our HA. Is that correct? All right. Remind your neighbor, how do we graph this? How do we graph that? Where do we start? Where do we start, Elijah? Paul's asked you to graph this. Yeah, +4. +4. So you plot your point at +4. What is our slope, everyone? A 1 or 1 over 1. So that means I go 1 step up, 1 to the right, plot your point, do it again, 1 step up, 1 to the right, plot your point, do it again, 1 step up, 1 to the right, put little dots in between. And that's our other asymptote known as slant asymptote. So keep bringing that down. Okay? How we doing? Yes? All right. Now, before we graph our graph, look up to the screen. We started with this kind. G of x equals 1 over x minus 2 plus 5. And how do we graph that, Mr. Cube? Well, I mean, once we have our coordinate plane and we graph our original one went here and here. But anyways, I'm going to go with our VA. VA is x equals, this one set it equal to 0, solve, so it's 2. So it would be 1, 2. And this is just a quick review of what we did before. Don't copy this. And then our HA is f of x equals 5. So 1, 2, 3, 4, 5. And then our graph would be here. 1 to the left, 1 down. 1 to the right, 1 up. You guys remember this one? Yes? All right. However, notice this red one, the red asymptote, is no longer like this on our new one. It's now tilted. You guys see it? So, check this out. Instead of going 1 to the right and 1 up, like right there, this one we go how many steps? 2. 1 to the right, 2 steps up. And then from here, 1 to the left, 2 steps down. And that's how you graph those slant asymptotes. Copy that, please. So, process. What is the first thing we did? We did long division, Mr. Q, because we only needed 1 on the numerator. So we did long division, found the answer until we got a remainder. From there we wrote our answer, which was x plus 4 plus a fraction, 2 over x plus 1. From there we moved the x plus 4 to the end. And then from there, the 2 went to the front, as Mario said, to the left. We filled the numerator with a 1. From there we found our VA by setting the denominator equal to 0. There it is. Our HA is everything to the right. And then from there we just graph our VA, which is -1, straight down. But this one, the HA, for those of you that got lost and didn't know where we got this from, this is that. I just wrote it bigger. And then it's a straight line, pretty much. We start at +4 of y. And then the slope is 1 over 1. That means 1 up, 1 to the right, 1 up, 1 to the right. And that's our other asymptote, known as a slant. Write that in there. Slant asymptotes. Asymptotes. All right, from 1 to 5, how comfortable are you with this so far? How we doing? Got 5, 4s, okay? All right, let me send you the screen so you can send me your notes, and we're going to do another one. All right, copy this next one, example 5Q. G of x equals x squared plus 5x plus 4 over x minus 3. Then make a little coordinate plane to the right as well from -8 to 8 for the domain and range. I'll give you a head start. And I'll give you a head start with the process for that one. Then we'll go over it together. Copy and go. Here goes. X squared plus 5x plus 4 divided by x minus 3. So, x times x is x squared. X times -3 is -3x. Subtract. Don't forget to distribute that here and here. This cancels. We're left with 8x. Bring down the next term, which is plus 4. From there, what times x gives us 8x? Positive 8. 8 times x is 8x. 8 times -3 is -24. Subtract. Distribute that here and here. So this cancels. That leaves us with 28. That's our remainder. Hands if you got that. All right. So, what's our answer, Mr. Q? Well, the answer is x plus 8 plus 28 over x minus 3. But this has to go at the end. This has to go in the front. So we end up with 28 over 1 over x minus 3 plus x plus 8, and all that equal to g of x. All right. Hands if you got that by yourself? Yes? All right. So, VA, x equals 3. Hands if you got 3. All right. Yeah, you set that equal to 0. There it is. HA, f of x equals to this, x plus 8. All right. So let's graph those. Let me zoom out. Our VA is at 3. Our HA is x plus 8, so I start at 8. And our slope is 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1. You know what? Let me wipe this out from the top. All right, so I said at 8, go 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, and so on and so forth. All right, so our graph from here, where they both meet, 1 to the right, and how many up, everyone? 28. Am I going to be on the page? No, so I'll just make it somewhere up here. And then just graph your little curve. 1 to the left and 28 down. I'll just put it somewhere right here for right now. So you get the idea, yes? Because it's going to be somewhere way down there. So 28 steps because of this. But that's how it should look. Hands, if you got something like that. Something like that, yes. All right, send me your notes, please. Let me send you the screen. All right, example 5 mega Q, there it is. Example 5 mega Q, write that down. G of x equals x squared minus 5x plus 6 over x plus 1. You should be able to graph that one completely by yourself. Give you guys a head start once again, and then I'll call on someone so they can show us what they got. So make sure you sketch your coordinate plane on the side. I'll give you guys some time. Copy and go. All right, let's see. So by now you should have already done the division. So I need an equation, a new equation for that one. All right, check with your neighbor before I call on someone. What did you get? G of x equals what? G of x equals what? All right, Caesar, G of x equals 12 times 1 over x plus 1 plus x minus 8 minus 6. Hands, have you got that? That is correct. We need a VA. The VA is x equals negative 1. Is that correct? Because you set this equal to 0. So negative 1 is right here. And then our HA is f of x equals x minus 6. So where do we start? At negative 6. 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, or the other way. So let's see, our graph, 1 to the right, and how many up, everyone? 12, so we should be somewhere up here. And 1 to the left and 12 down, so somewhere down here, 12 steps down. Hands, if you got something like that. Let's go, Enrique, let's go. Woo. All right, send that in, please. All right, so I'm going to stop right there. Those of you following on YouTube, I'm going to let you guys do the practice work. Once again, if you go to the video and stop it at the beginning, you're going to see the home play, or there's a code for Nearpod right there. See you guys next time. Peace.